Alright, hi everybody. This is Diploma Review here, and we're working through the chapter on permutations and combinations, and this is specifically about binomial expansion. So what we're going to do is we're going to find the term containing x to the sixth, okay? And what we're expanding here is 2x cubed minus 1 over x to the 14. Now it's really important to understand that there's a few different ways you can do this. But what I'm going to do is I'm going to be really close to the formula there. Now, I'm not going to worry about this first term, this first question here. We're going to focus on b. Remember that the general term of this expansion is going to equal n choose k, x to the n minus k, y to the k. And so now what I want to do here is plug in the information that I'm gathering from this binomial to the 14th here, and plug that in, and then I'm going to be looking for that term x to the sixth. Okay, so I'm going to plug this in. Now, first of all, I see that n is going to be 14, so this will be 14 choose k. X, now in this context, x is referring to the first term of the binomial, so this will be 2x cubed, and n is 14 minus k. And then y refers to the second term of the binomial, so 1 over x to minus 1 over x to the k. Can't forget about that negative there. That will make a difference. Now, I see that I've got x's in here. I've got two of them though, and what I'm looking for is x to the sixth. Now what this tells me is that every term in this expansion is going to have an x in it. The way I'm going to differentiate one term from the next is the value of k, the exponent. So I'm going to be looking for the exponent on x. I'm going to be wanting that to equal 6 and figure out what value of k does that. So what I need to do here, first of all, is I need to kind of spread this out. I need to get the x's out of these factors here. So I'm going to write this again, 14 choose k. And now I'm going to distribute this exponent to these two terms. These two factors, okay, in this expression right here. So this will become 2 to the 14 minus k. X to the, now you got to be careful here, the x is being cubed to the 14 minus k, meaning that this will be x to the 42 minus 3k. Okay, when I multiply this together, because remember I've got a power of a power, so I'm going to multiply the exponents, so the 3 times the 14, 3 times the negative k. Over here I'm going to have negative 1 to the k, and I feel far more comfortable separating that negative from the variable here. I know some people are okay working with it like that, but I prefer to separate it. And now I've got this x in the denominator. I'm going to bring that x up to the numerator, but if I do that, I'm going to have to give it a negative exponent. This will be x to the negative 1 to the k, which will make this x to the negative k. Okay, now what I want to do is bring those two factors of x together. I mean, everything's being multiplied together here. Order does not matter in multiplication, so I'm going to bring the numeric coefficients here up to the front. So I'm going to bring the negative 1 up to the front, to the k. And I'm going to make this here x to the 42 minus, well, when I put those together, I'm going to get minus 4k. Okay? Because I'm just going to add the exponents together. And when you do that, negative 3 plus negative 1 is equal to negative 4. Now, this is exactly what I wanted to see. I wanted to see this expression with this one factor of x to this power. I'm looking for the term that's got x to the sixth, so really what I want here is I want this exponent on x to be equal to 6. Now I'm going to just do this off to the side over here. I want 42 minus 4k to equal 6. So I'll bring the 4k over to the right hand side, bring the 6 over, and I'll divide by 4 and get 9 is equal to k. And so now I know what the value of k is in this expression. So now what I can do is I can plug this in, and this is going to be the 10th term, will equal 14 choose 9. Okay, this will be 2 to the 14 minus 9, negative 1 to the 9, and then I already know that this is going to end up being x to the sixth. Okay, so now putting that all together, plugging this into my calculator and evaluating it here, we will get negative 64,064 x to the sixth, and that's the term that I'm looking for. I know it takes a lot of work here. This is fairly algebra intensive, but I think the most direct way to do this is just to use the formula and get really good at simplifying the exponents.